Okay, so in this tutorial, we have two topics to talk about. The first one is double integral over general regions, which we started last week, but we didn't do any question on that. And the second topic is double integral in polar coordinates. If you took 232 recently, those should be a review for you. So hopefully everyone still remember 232. Anyway, double integral over general regions, as we talked about last time, instead of a rectangle we have general region, then you can define your function f in this way. Okay, so when your xy is in D, then you make it f of xy. When it's not in D but in R, then you make it 0. So you define it by this piecewise function, and then our double integral um, can be computed in this way. Okay, and for our D, the region D, we have two different types. The first type is called type 1, and the second type is called type 2. So type 1 means that, okay, type 1 means that your region lies between graphs of two continuous function of x. Okay, so the key point is they are continuous functions of x. Okay, so your x is in between two numbers and your y is in between two functions, continuous functions. In this case, if you have that, then this is how you compute your integral. Okay, so and then we have, those are examples of type 1 region. You see that it lies between two continuous functions. Your x is between two numbers and y is between two continuous functions. Here is the same, and same for here. For type 2 region, remember that your functions, okay, your function is like x equals to something something y. So it's a function of y. That is why your y is between two numbers and your x is in between two continuous functions. And if you have that, this is how you compute this. And those are examples of type 2 region. So here is an example. I want you to evaluate the double integral. So after you finish the question, let's see, let me know your favorite, what do we want to know? Favorite movie, how's that? So favorite movie, to show that you finished the question and I can take it up. If you don't have one, just let me know you finished, okay? We'll wait for 3 of you to finish the question and then I'll take it up. Oh, Hachi, a Dog's Tale. I watched this so many times and always cry. Oh, like, I know what's gonna happen already, but every time I watch it, I always cry. Oh, 2 of you have the same favorite movie. Interesting. Yeah, I have a dog, so it's like... Oh, do you guys know I have a dog? No? Oh, that means I never showed you my dog. Okay. Well, it's kind of late to do introduction of myself, but I'll do it anyway. Actually, I'll do it after we finish this example, and I'll do introduction. Okay. Anyway, here, first of all, let's check the region and check if it's type 1 or type 2. We can see that your x lies in between two numbers, and your y is in between two continuous functions, so this is type 1. Since this is type 1 region, okay, since this is type 1, we can just use the formula above. So let's go back. So you can just use this to compute your double integral. Okay, so this equals to a is 0, so 0 to 4, and 0 to square root of x, y over x squared plus 1, dy dx. How do I know it's type 1? Okay, that's okay. Here, this is type 1. Compare those two. Do you think they are similar? Those two? The difference is that for type 1, your y lies between two functions of x. For type 2, your x lies in between two functions of y. That's the difference. Okay. Alright, so when it was type 1, we used this formula to compute it. The rest is just computation. And I hope all of you know how to do this, but I'll do it anyway. So this equals to 1 over 2, 0 to 4, and this is x over x squared plus 1, right? Yeah, dx, which equals to 1 over 2 times 1 over 2 log x squared plus 1, and this is from 4 to 0, and 4, so 1 over 4 times log 4 times 4 is 16 plus 1, 17, minus log 1, which will give you 1 over 4 log 17. So this is the final one. Don't really need to graph it. For this type, you just need to know if it's type 1 or type 2, and use a formula to compute it. Okay, anyway, any question? Do we have any question? No? No question? No? Okay. So if no question, let's do example 2. So I want you to find the volume of the given solid, which is bounded by the cylinder x squared plus y squared equals to r squared, and y squared plus z squared equals to r squared. Write down the question and I'll introduce myself properly. Oh yeah, I think I didn't make the slides to introduce myself to you guys. Instead, I just talked. Okay, everyone has a question ready? Because I need to switch to something else. Anyone need more time? Oh, you don't need to copy it. I sent you the worksheet already. Okay, so let's go to my 102 winter note 2024. This one, tutorial 1. Here I have some introduction. Okay, so let me erase this. Okay, so I graduated last year. I think I did this already. Graduated last year, did math and chemistry major, biology minor, and this is not 102, so this is my first time TAing in this course. Is this 236? Yeah, 236. This is my first time TAing this course, and I have a YouTube channel which is mostly Math 102 stuff, but I post the tutorial recording in my YouTube channel as well. This is my email address. Your course, I don't know if I need to hold office hours, so this is not the office hours for you guys. Okay, and this is my sister. This is my sister. This is my cat. This is my brother. My brother. Oh, you're checking my YouTube channel? I failed that challenge. Anyway, and this is my cat now, and this is my dog Brownie. Oh, and I was feeding. So when I was living in Mississauga, those animals came to my house regularly, so I was feeding them regularly as well. So yeah, I don't know their names, so I named them. I named this cat Orange. So this is Orange, this is Juice, and this is Grapefruit. Because like that period of time, I was craving for orange juice for some time, for some reason, and then like juice and grapefruit, they look really similar. They are different, but they look really different. Not different. They are different cats. And then I remember a few nights the raccoon family. You can see 3 here, but there were 6. So another 3 somewhere there. Anyway, so they all came to my house, and then I gave them cat food. Yeah, so that's about me. Yeah, that's about me. A proper introduction. Okay, go back to your course. This is the second tutorial, right? Is it? Yeah, I think it is. Yeah, it is. I'm slightly confused because for 244, ODE they started tutorial in the first week, so for this week they'll have their 3rd tutorial, but for this course, this is the 2nd tutorial. You finished day 7. Okay. Let's take it up, actually. Let's take it up. It's been a while. So, okay. Well, they can give you something like this. So what I'm gonna do is I'm gonna show you the graph first, and then we'll do the question later after we finish the graph. After we talked about the graph. So, where is my graph? Okay. Okay, now can you guys see the graph? Okay. The red one is x squared plus y squared equals to r squared. So this is your z-axis. This is your x-axis, and this is your y-axis. So the red part is x squared plus y squared equals to r squared, and the blue part, okay, the blue one is y squared plus z squared equals to r squared. And what you need to compute is their intersection part. Okay, so it's this part, the intersection part. So I'm gonna rotate it a bit to show you what does it actually look like. Okay, so it looks like the blue line. Hold on, let me see. No, the blue line is z axis. The red line is y axis, and then the green line is x axis. Okay, let me write. Red is z, no, red is wait. Blue is Z, red is Y. Blue is Z, red is not Y, is X, sorry. And green is Y. Yeah. Blue is X, blue is Z, red is X, green is Y. So I'm gonna rotate it a bit. So this is what the graph look like. What I'm gonna do is, let's see, Z, X, Y. Red is X, so let's put it this way. So what I'm gonna do is I'm gonna compute part of the solid. I'm only gonna compute this part of the solid. So when all X, Y, and Z are positive, okay, so only this part. And since it's symmetrical, after I'm done, I can just times 8. Okay, you might ask me why is it 8? Because, well, let's look at the top part. When Z is greater than 0, greater or equal to 0, then you have 4 parts. 1, 2, 3, 4. And then when Z is less than 0, you have 4 parts as well. 1, 2, 3, 4. So in total, you have 8 such parts. So I'm only computing when X, Y, Z are all positive, all non-negative. Okay? Now go back to my iPad. Okay, so that's my plan. So let's write it down. So by symmetry, the volume is 8 times the volume in the first octet, which is this part. Let me draw it out. So I'm only gonna draw the part I'm gonna compute, and I'm only drawing it X and Y axis. So this is X, Y, and this is X squared plus Y squared equals to R squared. And here is R0, here is 0R. So this is my D, this is my region D. Okay? So if I compute this part volume will be from 0 to R and then 0 to, so 0 to R, I'm talking about Y. For X is from 0 to this graph, but you need to write it as a functional. So since X squared plus Y squared equals to R squared, your X will be square root of R squared minus Y squared. Okay? So because of that, we know that your X is from 0 to square root of R squared minus Y squared. And you need f of xy as well. So f of xy equals to z, where z can be found here. So z equals to square root of r squared minus y squared. Alright, so you put that here. And then dx dy. Alright, the rest is just computation, so x times square root of this. This is 1, x equals to square root of this, and 1x equals to 0, dy. That's gonna give you r squared minus y squared dy, which equals to r squared y minus 1/3 y cubed. This is when y equals to r and 0. So this will give you r cubed minus 1/3 r cubed, which is 2 over 3 r cubed. And the volume we want is 8 times of this. So V equals to 8V1, which equals to 16 over 3 r cubed. Okay? I'm gonna move it to here. Question? Makes sense? Okay, nice. If that makes sense, try example 3. Or example 3 is much easier, so try it. Scroll up. Let me know once you are done. Okay, this time what do we want to talk about? Let's say favorite song. When you finish the question, tell us what's your favorite song. Is this polar coordinates? No, it's not. We're not there yet. After this question, we'll talk about polar coordinates, but not now. A similar question came in 232 final. Oh, really? Huh, interesting. Favorite song, right here. Okay, seems like 2 of you finished the question. Let's wait for 1 more of you, and then I'll take it up. Or if you're not done but you want me to take it up right now, then we'll take it up. Okay, seems like 1 more of you finished then. I'm gonna take it up. So first of all, you need to realize, well, what is our region of integration? So what is our D? D is xy such that, okay, so this is dy. So that means this is y. So x is from 0 to 1. And y is from arctan x to pi over 4. Okay? Now let's draw it out. Where do I want to draw it? Let's draw it here. This is x, this is y. Your x is from 0 to 1. Your y is from arctan x. So arctan x looks like this. Okay? And we draw the horizontal asymptote. And this part, this is pi over 2. And it's from arctan x to pi over 4. So pi over 4 will be somewhere here. So this part, and here is 1. So this is the region we're looking for. This small part. Now they want you to change the order of integration, which means you need to, oh, let me write it down. Y equals to arctan x. Which means you need to write it, you need to, before we are talking about 0 is, x is between two numbers, now you want y between two numbers. So we know that y is between 0 to pi over 4. What about x? So x is from 0 to this graph. You want to write as x equals to something. So since y equals to arctan x, x will equals to tangent of y. So 0 less than or equal to x less than or equal to tangent y. And your y is between 0 to pi over 4. Okay, so switch the order. This equals to 0 to pi over 4, and then 0 to tangent y, f of xy dx dy. That's it. So this is the final answer, and this is a graph. Done. Question? It's not that hard. Question? No one has any question? Are we good? If we're good, type up a number in the chat. Okay, seems like we're good. Any question? If you don't have question, put a number in the chat. Okay, there we go. So I can continue. So let's move on from general region. Let's do double integral in polar coordinates. Okay? Polar coordinates. So the motivation is that for some region, it's easier to describe it using polar coordinates. That's why we're doing this, especially something like this. Well, anything involves circle or part of circle or something similar to circle. And this is just review. You can write your polar, you can transform your rectangular coordinates to polar coordinates in this way. Alright, and then there's something called polar rectangle, which is in this form, where your r is between two number and your theta is between two angle. Something that looks like this is called a polar rectangle. And if you have a polar rectangle, then you can compute your integral in this way. It's pretty simple. The only thing that people might make mistake is they are missing a r here. Make sure it's f of this and then r dr d theta. Okay? Thank you. It took me a while. Actually, not a while. It took me an hour to type everything up. Um, now let's look at the example. Again, I'll give you some time to try this out, and then I'll take it up. What do you want to talk about this time? Favorite what? Favorite food? Okay, favorite food. Right here, favorite food. In ramen, I think last week someone said their favorite food is ramen too. In another course. Anyone else finish the question? We'll wait for two more of you finish this, and then I'll take it up. If you don't know how to do it and you want me to take it up now, you can let us know your favorite food as well. Roast chicken, butter chicken, ramen. Oh, two of you have the same favorite food. Okay, let's take it up. Seems like all of you finished already. So, our first step is that we want to change it to polar coordinates. Okay, I'm gonna draw the region first. So the region in the first quadrant enclosed by the circle the line and this line. So that's gonna be, oops. So this is x squared plus y squared equals to 4 in the first quadrant. And then the line, this is a line y equals to x. So enclosed by this, and the y-axis, because x equals to 0 is a y-axis. So the region we're looking for is this part. Okay, the pink region is the one where we need to calculate. So this is R. Oh, and this is 2. Yeah, looks like a pizza slice. Yeah, I agree. Yeah, it's like a pizza slice. Anyway, now let's convert it into polar coordinates. So my R is gonna be R theta, such that R, so R is the length of this, so it goes from 0 to 2. And my theta is this angle, so that's gonna be pi over 4 to pi over 2. Okay, so that's my first step. I change it to polar coordinates. Now the rest is just computation. So this 2x minus y dA equals to, so pi over 4 to pi over 2, 0 to 2, 2x, x equals to cos r cosine theta, so 2 r cos theta minus r sine theta, because that's y, and then r dr d theta. Okay, now you can take out r, so that's gonna be 2 cosine theta minus sine theta r squared. So that's a function of theta multiplied by a function of r. So you can split them out. That's gonna give you from pi over 4 to pi over 2, 2 cos theta minus sine theta d theta, and then 0 to 2 r squared dr. It's just computation, so should be simple. 2 sine theta minus, minus cosine theta is plus cosine theta, pi over 2, pi over 4, and this side will be 1 over 3 r cubed from 0 to 2. So this will give you 2 plus 0 minus square root of 2 minus square root of 2 over 2, and that's going to be 8 over 3. So eventually you'll get 16 over 3 minus 4 times square root of 2. Okay, that's example 4. Any question? If no question, type, I don't know, type a number in the chat again. Okay, cool. That means no question. Double integral in polar coordinates, this is kind of similar as before, except now your theta, no, not theta, your r is in between two functions of theta. Okay? Before both your theta and r are between two numbers. Now we're talking about functions, and this is how you compute it. It's really similar as before. Now let's look at the last example. So use a double integral to find the area of the region. So for the people who entered early, this is what I was talking about when you just got in. Give you some time to think about it. What do you want to talk about? Favorite thing? Favorite pizza? How's that? Because we were talking about pizza. Okay, favorite pizza. Or like favorite topping of the pizza. So what's your favorite topping for a pizza? I like mushroom on top. What are we supposed to do? We are supposed to do example 5. Where can you find this? Did you join late? I'll send the slides again. I sent it in the chat at the beginning. Okay. And when you finish, I'm asking what's your favorite topping for a pizza? Put it in the chat in case you forgot. Favorite topping. Oops. It's enclosed by both of them, so it's like something bounded by both of the function. Does that make sense? I'll draw it out. I'm pretty bad at drawing this, but I'll draw it out so that it's more clear. So the highlighted part, those part, oops. This part and this part are the areas you need to calculate. It is symmetric, yeah. Yeah, my graph doesn't look like it's symmetric, but it is symmetric. It should be symmetric. take it out because we're running out of time. For the second question, the second part, I'm not gonna take it out because we don't have enough time. Okay. So what I'm gonna do is I'm gonna compute this part, and since it's symmetric, I can just multiply by 4. So I'm gonna call this part D. So by symmetry, the area of the region is 4 times of the area of D, where my D is r theta, such that r is in between 0 to, so 0, r, 0 to this line. Okay, this line is 1 minus cosine theta. So 1 minus cosine theta. And my theta is between 0 to power 2. That's my D. So my total area equals to 4 times the area of D, which is gonna be 4 times 0 to power 2, and 0 to 1 minus cosine theta, r d theta. Okay, when your fxy equals to 1, that's the area instead of volume. Okay, so that's it, and you just compute it. Yeah, the rest you can do it yourself. Okay. Any question? Anyone has any question? Yes. What's your question? What's your question? Still typing? Oh, double integral is used to calculate volume. Yes, I just mentioned that. When your fxy, you let it be 1, then it's calculating the area instead of the volume. Okay? It's in the textbook as well. So it's in the textbook. Let me get your textbook and I'll tell you the page. You don't need to apologize for that. It's okay. You too have a good day. Any other question? No problem. Do we need to? We don't need to. We don't need to. What's next for calculus after 236? Oh, after 236, you're done calculus. You can do analysis, like real analysis, which is not computation anymore. You need to do proofs. So that's 337. Yeah, we only have calc 1, 2, and 3. So 1 is 135, 136, 2 is 232, and 3 is vector calc, which is this course. Any other question? The course is 337. No, you don't, this is not your homework. This is tutorial 337, real analysis. Your assignment, let me have a look at your assignment. You can leave now if you want to. I will have a look at your assignment. By your assignment, I can draw a graph if you want, so that you know what it looks like. Do you guys want me to draw a graph? Oh, I think actually you guys left already. I'll draw a graph in case you don't know what does it look like. Your assignment is 1 plus r equals 2. So your assignment is r equals to 1 plus cosine theta, and then r equals to 3 cosine theta. So what does that look like? I'm really bad at drawing, but you just know what I mean, and that's enough. Yeah. Why is it so hard to draw it? Okay, so 1 plus cosine theta is like what we draw before. Okay, so this is 1 plus cosine theta, and 3 cosine theta looks like this. Okay, and you need to calculate this region, the area of this part. Okay, that's it. Oh yeah, you joined before the previous tutorial ends. Well, it ends now, so bye. Bye for people in my first tutorial, and hello for people in my second tutorial. I'll erase everything.